What is deflection in suspension bridges, and why does it matter? Imagine standing on a bridge that gently sways under your feet. That movement is called deflection, and it plays a huge role in how safe and stable a suspension bridge really is. When loads like cars, trucks, or even strong winds press down on the bridge, the structure bends or moves slightly. This bending is what engineers call deflection. It happens because the cables, deck, and towers all work together to share the weight and forces acting on the bridge. Deflection is important because too much of it can cause problems. If the bridge bends too much, it might weaken over time or even crack. Excessive movement can make drivers feel unsafe or uncomfortable. In extreme cases, it could lead to structural failure, which is a disaster for everyone. That is why controlling deflection is a key part of designing suspension bridges. Engineers need to make sure the bridge can handle the expected loads without bending too much. A big step forward in understanding deflection came in the late 1800s. A scientist named Joseph Mellon developed a theory that explained how the cables and deck work together to share loads. This idea allowed engineers to design longer and lighter bridges. Instead of building very stiff and heavy structures, they could create more elegant and efficient designs. For example, the Manhattan Bridge, built in 1909, used these principles to span a record-breaking length of over 1,000 meters. It showed how controlling deflection could make bridges both strong and beautiful. Today, modern suspension bridges use advanced computer models to analyze how they bend under different loads. These models consider both the weight of the bridge itself and the forces from traffic and weather. This helps engineers design bridges that can reach incredible spans and heights. For example, the Akashi Kaikyo Bridge in Japan stretches over 3,900 meters and can handle strong earthquakes and typhoons thanks to careful deflection control. In the end, deflection is the bending movement of a bridge when it carries loads. Managing it well is essential to keep bridges safe, durable, and functional. The history of understanding deflection shows how engineering progress has allowed us to build record-breaking bridges that push human limits. These innovations have made it possible to connect distant places and create engineering marvels that stand the test of time.